my friend. Yes, the tough dog, the watchdog of our math video. Hey, let's get started, alright, shall we? Welcome to another math video, my friends. We are going to be looking at a new objective. Topic C, same old, right? Making like units numerically. However, our objective is always new, every time. It says here that you are going to be able to solve multi-step word problems. Oh my goodness. Multi, of course means many. You're going to assess reasonableness, like your teacher. Your teacher's very reasonable, we hope. Reasonableness of solutions using benchmark numbers. Part of this sounds familiar. You'll see the connection. These are not called application problems. This is the concept development. Mr. Wara goofed. Cross that out and bring on the blooper. Anyway, let's go ahead and get started here. I don't know why I got this little thing stuck in my head that, I don't know. This is kind of crazy, but it's just that whole Finding Nemo scene where, they catch the anglerfish and they have them like trapped with the goggles and the mask, and they're saying, yes, no eating here tonight. Whoo, no eating because you're on a diet. Anyway, I don't know why that is stuck in my head, but I don't know. Mr. Warren needs some help. Anyway, let's take a look at the problem here. We have in a race. It says the second place finisher crossed the finish line 1 1/3 minutes after the winner. Okay. The third place winner was 1 3/4 minutes behind the second place finisher. Okay. The third place finisher took 34 2/3 minutes. How long did the winner take? Ooh, here's a problem for you. All right, let's go ahead and get our pen out, because we are definitely going to be addressing the RDW. And that's that read, draw, and write. Okay, and I think we're going to actually need to bring out the old, not the shape pen, the shape. A shape to go ahead and address this. First of all, let's go ahead and draw this to show each one of the runners here, people cross the finish line. Now I'm putting 3 in a row. Okay, because you can almost think of this as their path. Now, one thing that we did learn in the problem was that it did say that it took the third place finisher that long to finish. That might seem like a long time, but, well, we really don't know how far they ran. Did it say? It didn't, but that may actually be a very good time. So we're going to go ahead and write his time here. This person got third place. Now, this is important to know when we write this because, oh, that was kind of sloppy, because when we actually put the time, remember, the time that's less is the better time. It's not this time. It's the time that's actually, oh, it's still doing it. Okay. Yeah. My pen is having some problems. That means that the other two have to be less. Does it tell us that? It does say this. It says in a race, the second place finisher crossed the finish line 1 1/3 minutes after the winner. So let's call this guy the first place since he's the winner. And then we'll call this guy the second place. So far, so good. Getting my magic pen. I don't know quite what for. Oh, that's right. I wanted to, yeah, that's right. I was going to write a code word. Do I have one, though? Let me think. I actually don't have one. I need to think of one. Oh, okay. We'll do this one. And this is that letter right there. I stopped. Ooh, and it's going to do that. Again, the letter C. Which I know you see, C for kitty litter. No, that's with a K, actually. C for cat. All right. Anyway, now the first place winner is obviously is going to have the least amount of time. The second place winner will be, a little bit more time than the first, but a little bit less than the third. This is the pattern here. So if we have the first place winner, we don't know how fast he is. All we know is he's 1 3 minutes after the winner. Okay, so let's go ahead and put this then. For the first place, I'm going to cross right into my problem here because I need that space. I do. And I'm going to put a big question mark right there in my problem. We don't know what he had. We just don't know. But what we do know is we do know that his time's going to have to be a little bit less. So let's just do this. Kind of try to keep it the same shape. This is going to be hard. Be nice to me. Are you going to go this way? Yeah, there you go. Yeah, you know, something, we'll just say it's like that. Okay? Really doesn't matter. This little space here, though, is going to show this part here is going to be that minute and a third. See? 1 and 1/3. Because he... Oh, did I lose my... I did, didn't I? I lost my little question mark there. Okay. So we didn't know that time because we made a new one here. And that was 1 and 1/3 minutes after the winner. So that's basically what it's saying is that's how much longer it took him on time. And I see a problem here because, you know, I think I'm going to just make this guy here a little bit longer. So we'll say that this one here is there. That works for me. And for this guy, we're just going to have to... Can we stretch him out? Cool. Oh, wow, that worked out really nice. Thank you. Smart. All right, and then, of course, that would mean here the third place finisher was 1 3/4 minutes behind the second. Means it took him that much longer after the second place. I could see where this could get really confusing. But basically, it's just that we have a winner that we don't know how fast he went. And now we're comparing it. We're comparing, basically, we know that he took a little bit more time, so we're adding that time on. We're saying whatever the winner's time is, it's going to be 1 1/3 minutes longer. And whatever the second place winner here is, we do know that it took the third place winner 1 3/4 minutes longer. So now when we look at that, how could we set this problem up? Well, we need more room, first of all, so I'm going to go ahead and extend this page. And let me go ahead and get, okay, starting to glitch on me again. Okay. Okay, so let me go ahead and write 34 2/3 minus 1 3/4. This is going then, we can quickly put this into what, 12ths here. Let's go ahead and do that. We'll put this into 12ths, which means that's going to be times 4. That's 8/12ths. Here, we're going to go ahead and put our 1. And again, 12ths means that's going to be 9/12ths. That's what that equals. And then we have 34. Now we can do, ooh, this is a big problem here. Look at that. Can 9/12ths take away from 8/12ths? We can't do that. You got a couple of options here. You could put this entire number in, you know, like an improper fraction and do it that way. Or, honestly, I think that's going to be a lot of work. So what I'm going to do here is I'm going to take one of these holes here and add it to this guy. So if I take one hole away from him, that means I'm going to have 30. Oop. Mr. Warra, that's not my 33. I got a little too crazy there with the pen. All right, 33. We'll try that again. And I took 1 away. Well, one hole here would be 12/12ths, correct? So 12/12ths. If I add 12/12ths plus 8/12ths, you can see I'm going to have 20/12ths. Now, this amount is still equal to that, okay? And then I can subtract, and I can put the problem out how I had it. Now I continue on. Now you can see here I'm going to have 20/12ths minus 9/12ths is going to leave me with, it's going to leave me with 11/12ths. So 11/12ths, and then I have 33 minus 1. Well, 33 minus 1, let's just do that first. That's 32. And then, of course, with my 11/12ths. Basically, I'm done. This is the second place guy right here. And that's his because we took this third place, and what his time was, we subtracted the time that the second guy did faster. So now his time's a little bit faster than his. So this is third. And I'm going to write it right inside here. 34 2/3. And then this person's time was 32. As you can see, he got finish a little bit faster. So he's even going to be a little bit faster. So we'll take the 32 and 11/12, hence our multi-step problem, and we're going to subtract that by 1 1/3. Okay, because this is the how much faster he did it. Again, looks like we have 12ths here because we already have our 12. So we don't even need to change that. 32 and 11/12 subtracted by 1, and then 1/3 is the same as 3/12. Maybe you recognize that if you had that common denominator. Not 3/12, I'm sorry. That would be 4/12. I'm thinking of quarters, not thirds. A third, that would be 4/12. Okay, now we can go ahead and subtract 32. Oh, is this going to be an issue? It won't. 11 minus 4 we can do. So let's do the 32 minus 1, which is just simply 31. And then 11 minus 4, which is going to be 7. So now this one is going to be 31 and 7/12 minutes. Now this is based in minutes. Now a lot of times, does it say how long to take the winner take? It doesn't say that we have to put it into minutes and seconds. It seems kind of weird to leave it like that. I'm going to get another color here and just show you how that can be remedied by basically changing this. If you have 31, and this is minutes, definitely means we have 31 minutes. So let's go ahead and show how we could convert this. So we have 31 minutes, and then we have our 7/12. And so this is all based on minutes. Well, the way we could take a look at that is like this. There's 12 in just the clock. When you think about it, there's 12 numbers on the clock. Each number from 12 to 1, 1 to 2, and so forth around 3 is actually 5 minutes. I'm looking at it this way. If you have 12 on the bottom, that means that this has been broken up into that many seconds, because this is based on minutes. So 1 minute is 60 seconds. So if I took my 60 seconds on the clock, I could think of it as there's 5 seconds, 10, right, 15, and the 15 would get me to the 3, and then another 15 to the, another 5 to the 4, and so forth, until you get to 60. Well, I have 7 of those. So couldn't I just say that 7 times 5 seconds, because that's how much time for each number, is equal to 35 seconds. And that sounds right to me, because if I had 6/12, that's half. That would be 30 seconds. 30 seconds is half on a minute, on a clock. So 31 minutes, and I'm going to put MIN, and 35 seconds. And that's normally how we would write a time for running, rather than the 7/12 sounded kind of weird, okay? But that's how they gave it to us, because we're practicing our fractions, and that's why they gave it to us that way. So here, let's go ahead and look at the next problem, because we're just doing these 2 problems, and that will be it. And I think I did give you a code letter, and here's one more that likes to do that. That's right. It's exactly what you think it is. Don't draw 2 of them, okay? Just 1, okay? Kavish? That's right, just 1, not 2. Okay, now let's go ahead and take a look at our problem here. So Sam used 1 3/4 kilograms of salt to melt the ice on his sidewalk. Ooh, that went all over the place. He then used another, 3. Oh, we come up here. Yeah, pen been glitching the entire time. I've had to come in here. Oop. All right, now come back. There we go. Sorry, I'm going to have to reinstall the software again. All right. Try to move that out of the way. Well, let's move that down since it's not letting me get up on there. He then used another 3 4/5 kilogram on the driveway. If he originally bought 10 kilograms of salt, how much does he have left? And you probably have been thinking, yeah, we're talking subtraction here. And I think that is it, because we're having a total here, and now he's using so much to melt, the ice on the sidewalk. He used another on the driveway, showing these 2 different places. So this whole problem is based on that. Oh, it's not going to let me change my pen now. All right, that's going to be a problem. That will be a problem. Okay, so we can take this and call that the total of 10 kilograms. That's the total amount of salt that he has, because he even uses the word originally bought. Now you can see so much here, 3 4/5 kilogram. And this is going to be the driveway. All right, so we look at how much salt did he use. It was 1 3/4. That was for the sidewalk. Okay, lost my cursor again, so I'm going to come over here. I'm just trying to get through this video, having all kinds of malfunctions here. All right, just not working really, really well. And then finally, this is the what we don't know. We'll go ahead and put the question mark because we don't know how much would be left. So let's go ahead and, okay, we need to add these two numbers so we can find out that third. Let's add these. And this is 1 3/4. Okay, and of course you can see we have, keep coming over here to get my pen to show up because I can't see my cursor and then I don't know where I'm writing. Probably need to do this too. Let's see. So I have 20ths here. So let's go ahead and show that as 20ths. Of course, 4/5 is 20ths is going to be 16 20ths. You may be able to see that by multiplying both the top and the bottom by 4. Gives you that. Plus, and we'll do the same thing here, multiply both top and the bottom by 5. It's going to give it 15 20ths. That way we can add them. And now you can see we have 4, but we're going to add the 16 plus 15, which is 31, over 20. So we have this really large improper fraction here. We can add the 4, and we have one more whole in there that we can take out, and that's going to leave 11 left over 20. Now you can see we have 5 and 11 20ths. That's the first step. This lets us know what these two were added together. Now we can subtract our 10 kilograms. Now that we know this amount, we can take our 10 kilograms, subtract the amount of salt that Sam used on his driveway and his sidewalk to figure out how much would be left in that probably big, huge bag. So let's go ahead and take the 10 and subtract our 5 and 11 20ths. And we do that, and you can see, now you might be going right away, oh, this is this really what I think it is, Mr. Moore? Really easy. I just have to subtract the two whole numbers and I'm done. Well, let's see. I think that might be the case, because if we take 10 minus 5, we end up with 5. Okay, and then we have 5, and then unfortunately here we have one more thing we have to do. We have the other 11 20ths, so you can't forget about that. It's tempting to do that. Now when you add, you can do that, but when you're subtracting, remember this was that whole amount. These were together. So now we have 5 minus 11 20ths, but that's not so bad, because if 20 20ths is one whole, I can figure what would be the difference of 20 20ths and 11 20ths, and that's actually 9 20ths. So what I'm going to do, I'm going to take 11 20ths from that. Let's just call the 5 is 4 plus 20 over 20. Okay with that? We'll call him that. That way we can say if you take 11 20ths from 20 20ths, so 20ths, minus, you're going to end up with 9 20ths. Okay, 11 20ths. Okay, in order to make a whole, we need 9 20ths. We're going to take that 11 20ths from that 20 20ths, and that would leave us 9 20ths. And from there, we could go ahead and say, well, then that's 4 and 9 20ths. And that's actually the answer right there. I kind of separated it. It's all together. And, of course, kilogram. Okay, and now I'm going to come out here, and I'm going to go ahead and give you, what is it? I have no idea. Let's give you this one. Because, my friends, this basically ends the video. That's it. It's a short one. I sure hope it's a short one. Again, apologize for my pen acting up on me, but it does that sometimes. We just kind of have to roll with it. All right, guys. Hey, live long and prosper, my friends.